of projection is given to be 45 degrees. So the maximum height reached is 98 meters. If you go back to the sessions, we told for an angle 45 degrees, range is maximum. So again, I have solved sufficient number of problems from the chapter two-dimensional motion. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. In this session, we will continue solving problems on the chapter Motion in Two Dimensions, what we also called as motion in a plane. The first one, the problem says, a ball is thrown into air with a speed of 62 meters per second at an angle of 45 degrees with the horizontal. I have to calculate maximum height attained, horizontal range, and time of flight. So velocity of projection is given to be 62 meters per second. Angle of projection is given to be 45 degrees with the horizontal. First, I will calculate the maximum height attained. So, all of us know the expression for maximum height. So, maximum height is given by u square sin square theta by 2g. It is mandatory in this chapter you thoroughly know the expression for maximum height, time of flight, and horizontal range. So on substituting, u is 62 square. This is sin square 45 degrees divided by 2 into 9.8 g, acceleration due to gravity. So h is 62 square into sin 45 1 by root 2 whole square by 19.6, which is equal to 98 meters. So the maximum height reached is 98 meters. Next we calculate horizontal range. Come on students, what is the expression for range? U square sin 2 theta by g. Again, this is 62 square sin 2 into 45, 9.8. Sin 45 is sin 90, which is 1. Therefore, range is nearly 392 meters. And finally, time of flight T equals 2u sin theta by g, 2 into 62 into sin 45 by 9.8, which eventually turns out to be 9 seconds. So by knowing these expressions, using clock's table, very easily I have arrived at the solution. The next problem, very interesting problem. A bullet is fired at an angle of 60 degrees with the vertical. Gamansi, it is not the horizontal. So we are firing a bullet at an angle of 60 degrees with the vertical with a certain velocity, and it hits the ground 3 kilometers away. So it is hitting the ground 3 kilometers away. Is it possible to hit the target 5 kilometers away by adjusting the angle of projection? If not, what must be the velocity of projection for the same angle of projection? Now, to begin with, here theta is 90 degrees minus 60 degrees, which is 30 degrees. This is because very clearly it is specified that the angle is made by the vertical. So it is 90 minus 60, which is equal to 30. Now we know range is u square sin 2 theta by g. Expression for range or R is u square sin 60 by g, or here u square becomes equal to, so what is u square there? Rg divided by sin 60. So I have simply used the expression for range, u square sin 2 theta by g. Theta is 30. So sin 2 theta is sin 60. So u square is r into g divided by sin 60. Now, when is range maximum? So we have maximum range is u square by g. If you go back to the sessions, we told for an angle 45 degrees, range is maximum. So 2 into 45 is 90, sin 90 is 1. So maximum range is u square divided by g. Now substituting for u square, so R max is R divided by sin 60, or R is 3 kilometers, 0.866, which is 3.46 kilometer. So now therefore it is very, very clear that this is less than 5 kilometer. So I need to adjust my velocity of projection. So substituting here, now u square. Now what is u square equal to? R into g. Now this is 5 kilometers or 5,000 meters. Again 0.866. On simplification, this turns out to be 237 meter per second. So this is the velocity of projection. The next one. A stone of mass 0.5 kg is tied to one end of a string and whirled along a horizontal circle. Whirled means it is rotated. So a stone of mass 0.5 kg is tied to one end of a string and is rotated along the horizontal circle of 1.2 meter radius. If the period of rotation is 5 seconds, calculate the tension in the string. So we are rotating the stone along the horizontal circle. Tension in the string is nothing but the centripetal force. So first we are asked to calculate the centripetal force. So therefore, we know in this case, it is m omega square r. So this is m, omega is 2 pi by t whole square into r. Mass is 0.5, 2 into 3.14 time. So this is just tension in the string. This is time is 5 whole square into 1.2. So on simplification, this is 0.94 Newton. Now he says, if the braking tension is 1.5 Newton, calculate the maximum speed with which the string is rotated and the time period corresponding to this rotation. So we know, again, F equals mv square by r. So v square is f into r by m, or v is root 1.5 into 1.2 divided by 0.5. So the maximum velocity here is 1.89 meter per second. Now I have to calculate the time period corresponding to this velocity. We know v is omega into r, or omega is v by r. So 1.89 by 1.2. So this turns out to be 1.57 radian per second. So T is, now omega is 2 pi by T, or this is 2 pi by omega. So which turns out to be nearly 4 seconds. Step by step, evaluate by substituting. At what angle should a cyclist lean over from the vertical while negotiating a curve of radius 58 meter, speed 15 kilometer per hour? So V is 15 into 1000 divided by 60 into 60, which is nearly 4.17 meter per second square. Now we know tan theta is V square by RJ. Tan theta is V is 4.17 whole square. 58 into G, nearly 10. So theta is tan inverse 0.039, and finally the answer is 1 degree 54 minutes. So again, I have solved sufficient number of problems from the chapter two-dimensional motion. In my next session, I come up with the next chapter. Until then, have a nice time. Thank you.